The problem which I am going to discuss now, you can see the full statement on the board. You can see the figure. There are two, one block here and two here. These two are equal mass. This is double the mass, 2m. And you can see the spring balance, pulleys and strings are massless. That is our assumption. Under that condition, weights, this 2 mg weight here and total 2 mg weight here will balance. So the system will be in equilibrium. System will be in equilibrium and the spring balance will read 2 mg because this mg down, 2 mg will be the total weight here. It will be the reading of the spring balance, which is also given here. Now an additional force is applied on C. Block C, an additional force is applied. Force mg. Already mg weight is acting down. That's its own weight. Plus another mg. This mg must be taken as a force equal to this weight only. It doesn't increase the mass of this. The mass of this block C is not increased. Only additional force mg is present. That's all. So total force will be 2 mg down. This will be mg only. Here it has its own weight 2 mg. So now the balance is disturbed. Total 3 mg weight is acting down here, only 2 mg acting down here. So system will start moving because with acceleration. So with the acceleration, system starting moving means tensions will change. Original tension was 2 mg, which is the reading of this. Now the tension will change. According to the new tension, a new reading, the spring balance will show. And that is the reading we want to find out. Find the new reading of the spring balance. Which direction D will move? That is, as a second question, D, because D will move down due to this pulley, it will move down because this pulley will be down. But at the same time, there will be a relative displacement between these two. This larger force means this will be moving down. This will be moving up relative to this pulley. So its actual direction will depend on the two acceleration values. Now, after this extra force is applied, this side is having a larger mass means this pulley will move down. Equal acceleration, this will also move up. That acceleration mark as A. This acceleration also will be equal A, but relative acceleration will be another quantity that will be different from A. This will move down due to extra weight, this will move up. So that acceleration we mark as A1, A1 for this. So its total acceleration will be, this acceleration will be A only, this also will be A, but blocks B and C will have some other total acceleration. That is, C will have A plus A1 downwards. A plus A1 down. B has A1 up, A down. So, its actual acceleration direction may be A1 minus A up or A minus A1 down. So, I will take the A1 minus A down case. A minus A1 down. A minus A1 down. So, A minus A1. A1 minus A means it will be up. This is because A1 is up. A1 minus A. So, both, I am assuming that This of course has no other option, only down. This has optional direction. It may be moving down or up. Now I am taking the downward acceleration because A is taken as positive, A1 is negative, so A minus A1 down. According to whatever you mark, you write your equations according to that. Now the tension. This tension will be T, this also T. So this will be 2T. This 2T will be the reading that we want, because that is the reading of the spring balance, because spring balance will read the force exerted at this hook of the spring balance, this side, to 2T. This will be 2T also. So 2T will be the reading that we want. So the new tension we have to work out, and that is the reading. 2 times that will be the reading. 2T means here also it will be 2T. So we have marked the forces on the system, mg plus mg, 2 mg down. Here also here 2 mg plus mg, total force here will be 3 mg, this is 2 mg. That is why this side is moving down. So we have to now write the force equations. Now to continue with the solution, I will delete the question statement. You can see the forces and accelerations marked on the diagram. For this A, forces are 2 mg down and 2T up. For this B and C, forces 2 mg down for C, mg down for B, and T, tension also marked. Accelerations A and A marked, this is up and this A is down. Relative acceleration A1, which is acceleration of B and C relative to pulley, A1 is up on this side because of lower force. Larger force makes A1 down. So this is moving down. So A1 and A are, this A and this A1 are marked in the correct directions here. This B only has difference of A and A1 as its real acceleration. So that depends on the A minus A1 side. Okay, that we come to that later. Now the force equations are already on the board. For A, 2T is the positive force, 2 mg equal to 2m into A. For B, we are marking the acceleration down as net acceleration, A minus A1 down. So mg is taken as positive force, T is negative force, and you get m equal A minus A1. Now C, the direction is down only. So 2 mg is the positive force, T negative force, m into A plus A1 is the acceleration. So we get that. The three equations are these three equations. Once you write correctly, rest of the solutions will be simple. Now our aim is to eliminate the accelerations, because what we want is the T, and the required answer, reading of the spring balance, depends on the value of T only. So as a first step, we are adding these two, last two equations we are adding. You are getting a 2 ma here, another 2 ma you can see on the first equation. So equating 2T minus 2 mg to 3 mg minus 2T, we get, solve it for T. You get 5 mg by 4. But T is not the answer for us. It is 2 times T, because reading is 2 times T. Reading of balance is 2 times T. 5 mg by 2 is the answer. That is the answer for the reading of the balance. Now we have another question asked, that is, what is the real direction of acceleration of B? For which we have to find the A minus A1 direction. For that, we don't need to solve individually the accelerations, we don't need to solve. Just look at the direction of B, the direction of A, that is A minus A1, sign of that you have to get using this equation. Sine of A minus A1 only we have to get. For that, A minus A1 has the direction given by A minus A1 is proportional to mg minus t. mg minus t is t is 5 mg by 4. Clearly it is a negative quantity because this is negative is larger, implies negative. So A minus A1 is negative. Negative means our original marked direction is not the correct direction. It is A1 minus A up. So acceleration of B implies acceleration of B is A minus A1 being negative, we have acceleration B is up, upward acceleration. So we can, if you want, you can write down the three acceleration directions. Directions of the three accelerations you can write down. So acceleration of A is, A we have is up. Acceleration of B is, already we have seen it to be up only, and acceleration of C also. C only one option which is down. So out of the three blocks here, one block is moving, two blocks are moving up. A and B are moving up, C is moving down. Actually this is A-B direction only asked in the question, which we have identified as upward direction. I think you can now follow the solution. Thank you.